Okay, so a really long time ago, who knows when, somebody somewhere told you that if you add up all of the angles of a triangle, you know that it's equal to 180 degrees. Notice a couple of things, right? I wrote different lines, different little like tick marks. That's what I call them. So look at the tick marks. Okay. I gave them different amount of tick marks, basically just to indicate that I don't know if they're congruent. As of right now, they're not congruent, right? So they're not equal to each other. So it could be pretty much any numbers that we can think about for the angles. So what this lesson is going to try and show you guys is, well, why is it 180 degrees, right? I don't want you to just accept it as true. This actually has a proof, and the proof is you already have enough in your brain, in your notes, to maybe struggle with it and try to see how you can figure it out. So let's go ahead and let's see it. Okay, so right now, if you really, really want to and you really think you can, go ahead and pause the video and try it. You're going to do a little T-chart with the given and the reasonings and see if you can figure it out, okay? My hint to you is you're going to use that right there. That is going to be the most important thing that you're going to use. So go ahead, pause the video. One thing I will tell you though is I'm not going to do the proof, the T-chart here. I'm sort of just going to explain it. Maybe I'll do like a really rough proof here, but we'll see how it goes. All right, so given that you have triangle ABC, so which we see the triangle there, given also that DE is parallel, that's what those two lines mean. For those of you guys that forget, this is the same thing as saying parallel. So I'm going to go ahead, I'm going to do that just to indicate those two lines are parallel. Prove that a measure of angle A, which is talking about this one, plus measure of angle ABC, so based off of the name, it's this one, plus measure of angle C is equal to 180. So basically you're just trying to prove the theorem that we know already, that we've used so much. Okay, so let's go ahead and let's think about how we can do this. And one really, really important way is you're going to really just ignore one of these lines, and I mean either this line or that line. You're going to ignore one of those two to create your proof. So let me go ahead and let's draw something. So I'm going to draw, there goes my parallel lines, and I'm going to draw line segment, oops, sorry, that's like super not straight. There you go. A to B. Okay, that's the only one I'm going to go ahead and draw. So I'm going to go ahead and just continue the picture. So D goes there, B goes there, E is somewhere over here, and then C is somewhere over here. If you notice, by me choosing to ignore one of the lines, I really don't even have to consider some of these points because the angle isn't even there. Like, sorry, this is not even D here, that is C. So for instance, think about it here. This angle C, it doesn't pop here in this new diagram at all. So I don't even really need to draw it to begin with, okay? So what that means is I'm going to only focus on this angle right here. Now, look at angle A right there. We right now don't know what that is, but what we do know is that we have some alternate interior angles. Which ones? Let's go ahead and be a little bit more specific. So we have angle A and angle DBA. So if you notice, those are alternate interior angles. So this is what I'm going to go ahead and do. I'm going to start color coding these. Okay. Now, what do we know about alternate interior angles? Well, they are congruent, right? If you don't understand this notation right there, it's they're congruent to each other. So what that means is that this angle is the same measurement as this one. I'm going to color code them, okay? So that angle is the same one as that one. Now let's go ahead and do the exact same thing, but now for C. So let me change color here. So once again, I'm going to do the exact same thing, but now I'm going to try to involve C here. So there goes my parallel lines. Here goes my line, where this is C, and this one is B. Notice how the other letters like D, I don't really need because it doesn't even pop up. A, the angle doesn't even exist here. And then we're going to go ahead and call that one E. So based off of the exact same thing, we have that this angle and this angle are again alternate interior angles. So we say that they are congruent. Now, just being a little bit more specific, we can say that angle C and angle CBE. You can also call it angle EBC. It is completely up to you, but just remember that the vertex has to be in the middle. Okay? So far we have this right here. Sorry, let me go ahead and color code that for you. So we have this angle is equal to that angle, basically congruent. And I know it kind of doesn't look like it, but we're basically done already. Let's go ahead and let's think about why. So I'm going to go ahead and draw it right here on this side, this empty space. We're basically almost done, and let me explain why. Notice how I didn't even consider working with that angle right there in the middle. I didn't even touch it at all. Let's choose a different color. So, right, notice how that angle, didn't even think about it at all. But we don't really need to because it's already in a, I don't even know if I can call it a linear pair because those are three angles, but a linear triple if you want to call it that. Because let's really think about it. Angle DBA plus angle, I should probably be putting the M here, but plus measure of angle ABC plus, I'm going to go ahead and zoom out a little bit, plus measure of angle CBE. So think about what I just did right there. So DBA is this angle right there. ABC is the angle inside the triangle. And then CBE is this outside blue angle. Okay. Now, if you notice, that completely covers an entire straight line. So that's equal to 180. But now let's really think about why we're essentially done. Angle A is congruent to angle DBA. So right here, I'm going to go ahead and instead of writing DBA, I'm just going to write measure of angle A plus, I didn't need to do anything with this next one because it's already a part of the triangle. So measure of angle ABC plus, and now just the last part, right? This one here, CBE, but we already worked with it. CBE is congruent to angle C. So I can put measure of angle C. And in a very sort of, you're kind of like stumbling upon it, we basically showed already what we wanted to show. Measure of angle A plus measure of angle ABC plus measure of angle C is equal to 180. Now, I know that this for some of you might be like, okay, it makes sense, but when would I ever think of this on my own? It just takes practice. I understand that this is hard, but it just takes practice. It takes just being a little bit creative and honestly, just struggling with it. Okay, so there you go. This right here is the proof now. So this is the proof. You no longer have to just basically say, yes, I agree with what you're saying because you are the teacher. No, you can say, I know why it's 180, not because somebody just said it.